So, to start things out here, right, what we're going to talk about is dimensional analysis, right? And really all this is working with units in mathematics, which is a big thing in chemistry and physics. So before we get into specifically dimensional analysis, I just want to review cross-canceling, right? The concept from math, right? Where if you've got something like this, right, you can cross-cancel across an operation, right? 3 is on top here, 3 is on the bottom here. We can cancel those 3's out, right? And we're left with 1/2. The same thing can be done if we don't have any numbers, right? Got x in the numerator here, x in the denominator here. It's across an operation. We can cancel those out, and we get y over 1. Or, right, because anything divided by 1 is itself, we can just say y. Okay, measurement and units, right? We're going to measure a lot of stuff. We do a lot of measuring in science. We use some standard units. So length, volume, mass, those are the big 3 that we are measuring. For each of those, they have standard units, right? So for length, the standard unit is meters, volume, liters, mass, grams, although a lot of times in physics we will actually be working with kilograms, time in seconds, and temperature in Celsius or Kelvin, though primarily in Celsius for this class. The metric system prefixes. So I will give you a sheet with these and a whole lot more, but for right now, just write them down because you'll have some questions about converting metric units on the practice that I gave you. There they are. Pause the video, write them down. Okay. Converting units, right? The question being 10 meters is equal to how many kilometers or kilometers? So we always start with what we know. We know that we're looking for meters, and here's the rule with dimensional analysis. Whatever unit we start with, or is here in the numerator, right, that we're looking to get rid of or convert, when we have our conversion factor, which usually looks like a fraction, we want that to be on the bottom so it cancels out, right? Because we can cancel out across an operation, right? We can treat this like it's over 1 because anything you can just put it over 1. It's perfectly fine in mathematics. All right, so top to bottom, or in some cases, right, bottom to top, but in this case, no unit here. So we're going to go top to bottom. And we're just going to keep working across like that, all right, because decameters appears here. We want it on the bottom on the next step, so we can cancel it out, all right? Hectometers, hectometers. We're going to cancel them out. So if you look, the only thing that's not canceled out here is kilometers and kilometers, right? Which is what we want. Now, we can do this in one step, right? If we know how many meters there are in a kilometer, it'll make it much easier. Okay, so now that we've looked at how the units cancel out, I'm going to do this with some numbers. All right, here's the same thing, just with some numbers in there. All right, because we know we've got 10 meters. There is 1 decameter per 10 meters. There's 1 hectometer for every 10 decameters. There's 1 kilometer for every 10 hectometers. So how you do this math, right? It's just like multiplying through fractions, right? We say 10 times 1 divided by 10 right? Because fraction is just telling you top divided by bottom, times 1 divided by 10 times 1 divided by 10, right? The thing is, all these 1's up top, right? Anything multiplied by 1 is itself, so we can just think about 10 divided by 10 divided by 10 divided by 10, right? That's going to give us 0.01. Now, if you look, right, remember how we collapsed all these down in the last part when we were just looking at units? We can do the same here, because if we think 10 times 10 times 10, right, that's 1,000. 10 times 10 is 100. 100 times 10 is 1,000. So we can say 10 divided by 1,000, right? We know that there's 1,000 meters in 1 kilometer, so we can use that as our conversion factor. Meters cancels out. 10 divided by 1,000, 0.01 kilometers. Okay, so now you're thinking, well, why didn't we just move the decimal place? That's a whole lot easier. It's true, for metric conversions, probably is just a whole lot easier to move the decimal place. However, this works for things that are not metric. So, if I was to ask the question, your car's gas tank holds 12 gallons when it's full. If gas costs $2.34 per gallon, how much will it cost for you to fill your tank? Now, just like in the last problem, right, we're going to start with what we know, which is we know that we have 12 gallons that our tank holds, right? So we set it up as a fraction, 12 over 1. The other thing we know is that gas costs $2.34 per gallon, which is a conversion factor. Anytime you see the word per, right, you can think of fraction. $2.34 per, right, fraction, 1 gallon. And then we just do the math, right? 12 divided by 1 times 2.34 divided by 1, which basically works out to 12 times 2.34, which is 28.08. And then we look at the unit, right? Because we always need units. So gallons and gallons cancels out. We're left with dollars. So it costs $28.08 or $28.08. Okay. So now the question is, if we have $8.73, gas, as we know, costs $2.34 per gallon, how many gallons of gas can we buy? So again, right, we're going to start with what we know. We know that we have $8.37. So we set that up. $8.73. We put it over 1 because that's perfectly legitimate in math. Any number that's on its own, put it over 1, just so you remember that the 873 is in the numerator. Then we're going to use our conversion factor, $2.34 per gallon. But if you look, right, dollars in the numerator, gallons in the denominator, right? These do not cancel out. So here's the thing. Anytime you've got a fraction, right, you can flip the things in the fraction as long as the number stays with the unit, right? So 1 has to stay with gallons, 2.34 has to stay with dollars, but you can flip them right? Because it's still 1 gallon for every $2.34. And now, dollars cancels out. We do our math, and right, 8.73 divided by 1 times 1 divided by 2.34, which basically is just 8.73 divided by 2.34, which gets us 3.73. Right, dollars as our units cancels out, and we're left with gallons. All right, so we could buy 3.73 gallons of gas. Hopefully everybody sees how this works. So the main takeaway, units are important and should be with every number that has one, right? Units can be cross-canceled, just like variables or numbers in math. Metric units are associated with powers of 10, right? That's why they're so much easier to use than the English standard units. And also the one that I didn't write here, but that I talked about just on the last slide, anytime you have a fraction, you can flip that fraction as long as the number stays with the unit that it was with originally. You can flip it so that things cancel out correctly. So that is it for dimensional analysis. Go try the practice. If you've got questions, let me know.